We're going to start off by creating a new another file for that's going to actually hold our custom math library, and I'm just going to call it my math for the sake of this very simple tutorial. New file, and just call it my not new file, new folder. Or no, yeah, new file. Sorry, my math, lowercase. First letter is always lowercase.
Okay,
.js, and then math will be uppercase. Yep. And the first thing we always do is we put in a header. So
right.
/* at file mymath.js at module.
We don't do TypeScript. Maybe for IntelliSense or
no, I don't use TypeScript. No.
okay.
Because TypeScript encourages you to use like classes, and we're trying to avoid classes and go completely compositional functional programming. I suppose you can do completely functional programming in TypeScript, but the syntax is not something I'm used to, so that's module my math and description implements the math functions. It would help if I spelled right. Okay. Requires the rest of this we can copy paste from the header, the file header of our other one. The path, so I'm going to capture from the @ symbol on the requires all the way down to the end of the copyright, and then I'll just change the date. So copy paste is a good way to sort of move things along quickly. And today's date is the 13th. Okay. And yeah, then we're ready to do our other things. So we're going to say let path equals require path. Oh, you know what? We forgot to do our internal. Did I spell that incorrectly? I did. I don't know. Okay. Internal exports. Now we don't need the path, but I'm still going to do the internal external imports here, by the way. Even if we're not going to have any internal imports, we still want to have this as part of our code. It's part of a good template, and I always try to follow templates. And that's a good practice to be in. Oops, I want to make sure I save that. Okay. We want to go ahead and say let base file name. Actually, these are the same. Let's copy that as well. These two lines right here, we can copy them. It's the base file name and the namespace prefix, not the term. You're going out of the prompt, but yeah, it doesn't matter where you copy it from. It doesn't matter. You're just copying it, and then we're going to change this. We still leave it application. We don't really have full namespace, paths and stuff in this application because this application is so simple and small. So I'm just going to leave that application, and it doesn't really matter at this point. We want to start adding our functions. So we're going to add the four basics: add, subtract, multiply, and divide. So we'll say function add, and I'll put data1, comma data2. And the very first thing after we write the function signature, again, that's called the function signature right here on this line. After we write the function signature, we go ahead and implement the header. That's the very first thing we do. At function, it's called the add function. At description, adds two numbers together and returns the result. Okay, again, try to go complete sentences. Proper grammar, first letter of the sentence uppercase, and good punctuation. And then this param, kind of like when you're thinking about, grammatical sentence structure, right? You got to learn about your subject and the verb and the preposition, or however that with the English sentence structure is. Well, that's what we're kind of looking at here. You've got the function signature. And then inside of the function, inside the brackets, is going to be the function body, and then you have the function header. So you just sort of keeping that basic structure in mind, and that's when we talk about it, that's what we're talking about. And then this is the header, so let's fill out the header. You got your function add, description, and then you want to provide the type. So this param is in the brackets is the type. In this case, it's going to be an integer. And it puts a star in there, but we're going to fill in because it doesn't know. Star just sort of means like a wild card, but we're telling it that you know, the documentation, it would understand this to be an integer. And we're telling any developers that might look at it that it's expecting an integer. And then we add the description. So data1, make sure you get your at function and at description at the beginning up here. So add those. You have to have the at symbol in front of it, and then the description the same. And I'll just keep working ahead, and you just keep getting caught up.
Sure. And now I understand that this is a wildcard.
No. This was the wild card right there.
Oh, right. Well, the star usually signifies the wild card.
Well, in this case, it means this is it's just a comment. So this is like a comment body, or in this case, we're calling it a header.
But I was just wondering what the at
symbolized. Yeah, that's the syntax used by JS docs, and it sort of picks up on that, and then it'll auto-generate the documentation based on these pre-filled fields. Is basically what it's looking for.
Okay. Yeah, sure.
Yep. So get the description in there, and I'll continue on with the description for the data1 parameter, which is the first number to be added together. And the second one is the second number to be added together. And then we do an at returns in the brackets to specify the type of the return, integer, the sum of the two input numbers. And then we do at author and sign our code with our name, same as we always do. And date, today is 2023, 0613. Okay. All right. Yeah, you're doing good. You're actually getting a little bit faster, which is really good. I like to see that. All right. So then we're going to have our boilerplate code again here. And this is where we really start to get into more general boilerplate code. And so we'll write it out once, and then subsequent functions will start to have this. So we say let function name equals add.name and console.log backtick begin and $ curly brace namespace prefix like we did before, and then $ curly brace function name, and then outside the curly brace function. Then we'll have console.log backtick again. Data1 is $ curly brace data1. Okay, now I can copy paste that line, and we'll just do this again and make it data2. It's a little bit easier than. And I'll go ahead and do the end of the function as well before we do the body, so we complete our boilerplate function. So console.log backtick return data is : $ curly brace return data. Now it's going to complain about that because it doesn't know what return data is yet, or at least it should be complaining, but console.log, and actually for the end, I'll just copy paste the begin, put that down here, and change this to end. So we're logging when the function begins, what the function is, where it's from, and the data that's passed into the function. We're logging the return data from the function and when the function is done. So everything that can be known about this function is now logged. Return data. And later on, like I mentioned before, we're going to build a configuration system and our own logging system. We'll integrate them so the configuration system can control the logging system, and we can disable these logs from configuration flags. We'll see about how to do that. And then I've got commands where you could enable or disable those flags on runtime, and you can do really cool stuff. It's really neat. We'll get into that.
Can I use this for other libraries?
You can use this however you want. I mean, this is we're just learning like the basic practices. Okay, your line 36 can go away because we're going to come back up into the body of our code, or the body of the function, and we're going to fill out the actual function implementation, because everything we've written so far is just boilerplate code. Like, it just describes beginning, inputs, return, and end. Like, that doesn't really actually implement anything. Okay, so now we're going to get to the function implementation, where we say let return data equals 0, and if data1 and, it's a double ampersand, data2, That's how we do an and compound statement. If data 1 and data 2, then we'll say return data equals data 1 plus data 2. Okay, so basic mathematics, just adding those two numbers and putting it in the result in the return data, and we're logging that and returning the result. So that's pretty basic, and the next step after that is to do the subtract. So again, we'll try to do this so you get in the practice of it. We could just copy paste the whole thing and then change, but it's better to get into the practice so you get the muscle memory and learn a little bit here. So function subtract data 1, data 2, open the curly braces and go back up, and then we do the header. Just like we did before. We've got at function subtract at description subtract two numbers, one from another, and returns the result. Okay, in our param again, integer, and this one is also an integer, and description is the first number to be subtracted, the second number to be subtracted from, let's clear that up, to be subtracted. Okay, again, at returns, integer, and the description for the return is the difference of the two input numbers. Again, sign it with your name and your date, 2023-06-13. Okay. Now, the interesting part here is once we have done this header, we really can go up here and just copy and paste the contents, the body of this function above, and then we'll just edit this because most of this is boilerplate. So we could just copy the boilerplate code down along with the implementation, and I'll paste that there. But there's one thing I got to change is the name. So here we have add.name, and it's not add.name. It needs to be subtract.name. That's a very important. Let's always not forget that. Anytime you change or copy code, you have to review that code to make sure that you don't have any copy paste errors or forget or miss anything. And then we've got data 1 and data 2, and return data is data 1 minus data 2. Okay, yeah, but you're getting better. I mean, this is definitely an improvement, so let's keep going. The next one is multiply, which is kind of the same, right? Just a little bit different. Function multiply data 1, data 2, and there's our function signature. And now we're ready to do the header. At function multiply at description multiplies two numbers together and returns the result. Okay, again, input is integer and integer. Oops, I did, okay. The first number to be multiplied, the second number to be multiplied. I had a typo there. And then our return, that returns integer. And the description is the multiplication result of the two input numbers. Author, date, 2023-06-13. And again, we'll copy paste the body of the function, paste it in there, and we got to change that function name, multiply, not subtract. Again, just click, double click, copy, double click, paste. It's a lot easier. And then we multiply instead of subtract. And then we're ready for division or divide. We're going to call it just divide. So function divide data1, data2, and the header at function divide, and at description divides two numbers, one by another, and returns the result. It's a little bit tricky sometimes, the English, to make sure we're describing it properly, but going through the motions of thinking about proper grammar and sentence structure and how we want to describe it, what it is that we're doing, really helps not just you, but everybody else that might have to look at your code.
So maybe well, product is product. I mean.
Yes. Yeah, absolutely. That would be a exactly. You're thinking ahead. That's the exact proper way to think about this. I was thinking about that too. That's a better way of describing it.
I mean, I'm not great at math. I'm trying to get better at it.
Right. No,
like
you're
the
right.
theory of it, but
100%. You're going in the right. You've sort of captured the essence of the lesson, right? It's not just. I mean, I've just thrown stuff out here because that's what I did, but you've got the essence of it.
I mean, it's autocomplete. I mean, I am spoiled with Copilot.
True.
And stuff like that, but
True.
it's like I am trying to. I mean, yeah, I'm trying to be wholesome with it.
Yeah, absolutely. No, you're going in the right direction. You got the idea. And then data. We also got. That's the thing about programmers. Programmers tend to be pretty lazy, so it's difficult to fall into the trap. But if we're making sure that we're holding true to those ideals and principles, then regardless of whatever automation tools are making our lives easy, we're still holding true to that. The highest caliber code that we're producing. Now this is where we could do a little bit on that grammar. The first number to be divided, and I guess that this one is the divisor, right? And I think there's terms for this, like I forget what they are, but there's like the top and the bottom. There's like math terms for that. I forget what they are.
Quotient, I guess.
Yeah, something like that. There's these. Yeah, exactly. I'm not sure. But then, yeah, at returns. By the way, I think this has to be returns and not return, if I'm not mistaken. Integer. I think this at return needs to be at returns, I think. And there's all over my code base, I'm not doing that. So I probably am the number one person not following the returns there. But I think that's what it's supposed to be. The division result of the two input numbers. That's fine. At author and at date 2023-06-13. Okay. And again, we'll copy paste the body of our function. Come down here, change the name. Good. Double click copy, double click paste, makes it fast. And then we need to have data1 divided by data2. And we'll save that. And the next one, we got one more function to write. And now that you've sort of got the feel for how to write functions, you kind of notice that, and this is where we really get in, learn something new. So you write a function, it takes some inputs, it does some work, and then it returns some result. But that's not how all functions are written. There's some functions that we write that are special kinds of functions, and they're called, there's many different ways of writing code, of course, but there's a specific classification of functions called the recursive function. And recursive functions are very useful to do very interesting problems. They allow you to solve interesting problems in unique and interesting ways. So sometimes you just have to get a feel for when you're facing a problem that would best be solved by recursion. And we're going to learn how to do that here because the next function is best solved by recursion. You could solve it by other ways, loops and such, but it's a very elegant solution to solve it with recursion. What we mean by recursion is a function that calls itself. So I could write another, divide in here, divide, right, and call it and pass a number. You can absolutely call a function from itself, but we have to be very careful when you do that because it's very easy for the code to just get stuck in a loop where it's calling itself infinitely.
It needs to stop somehow.
Yeah, there's a halt condition or an exit condition. And so we're going to be careful about how we do that, but we're going to learn how to do this. So I'm going to start by writing this the same way we write any function. Function factorial. And we're only passing it just data because there's only one data. You don't need two operators to do a factorial. So now we'll do the header for that, same as we always do. At function factorial at description computes the factorial of a number using recursion and returns the result. Okay, and the param is of type integer. It's the number to compute factorial for, and returns integer the factorial result, and my name at author at date 2023 0613. Okay, and again we've got we can copy paste the body of our function up here because it's boilerplate, and the boilerplate doesn't really change. The only thing that does change is the implementation. So we're going to leave the return data in there. Oops, I got to change the name. Double click copy, double click paste. And we don't have a data 1 anymore, and we don't have a data 2, so I'll delete that and change this data 1 to just data because we only have one parameter coming in. Return data equals 0. We leave that the same. This entire thing is going to just delete that entire if condition because we're going to implement this something new here. Okay, so now comes the implementation of this factorial function, which is when things get really interesting. And so it's only a few lines, so we got to really look at this. If data equals, we do that tuple equals again 0. This is going to be our exit condition. So, and we generally speaking, you want to try to have your exit conditions or any sort of exit condition for your function. You always want to try to have that, very early on in your function. The reason why is because it's called the fail fast technique. So if you're not wasting a lot of CPU cycles processing stuff in the body of your function, if you can determine early on if there's an exit condition, right? So for the performance of your functions and the performance of your code overall, you always want to try to have, if there's any exit conditions or any failure conditions, you always want to try to put those as much as possible very early on, or at the beginning of your function. That way, your function doesn't sit there and spin doing a bunch of work that ultimately it could have not had to waste time doing, right? And so that's always good to think about. That's one of the reasons why we're putting this exit condition right up here at the beginning. So I'm just telling you that so you sort of get that thought process in your mind right now early on. So we say return data equals 1 because that's how this is going to work. We don't want it to multiply 0 times 0 because that would be 0, and then we would get a 0 result no matter what you pass in. So we always want to return 1 if we're hitting the 0th condition of this function. And then we're going to have an else here. And the else condition is return data. So the else condition here is the recursion condition. So this is where it's going to call itself. So return data equals data multiplied by factorial, and we'll pass data minus 1. So it's a little bit weird how it works, how it looks, but it's really interesting. Now you're going to see, because we've done all these console logs, when we call this, you're going to see it do some very interesting stuff on the screen. Basically, it's going to call factorial. Let's say, just sort of analyze this, how it's designed. You pass in factorial, and let's say we pass in 4. Or maybe, yeah, let's just say 4. So you pass in 4. This gets called with the number 4, and it's going to log it. It's going to say the number is 4, and then data is not equal to 4, so it's going to go to the recursion condition. It's going to say 4 times, and it's going to multiply, and by calling factorial with 4 minus 1, which is 3. So it's calling factorial again, which is going to come up here. Now it didn't actually do this multiplication yet because it's busy calling this function again, right? So it's calling factorial again with 3. 3 comes in here, again logs it with 3. Its 3 is not equal to 0, so it's going to recurse again. This is 3. 3 multiplied by factorial is 3 minus 1 is 2. So it's the same thing. It's going to call this with 2. It didn't do the multiplication again. Not yet, because it's busy calling this thing again. So 2 comes in here. 2 again gets logged. 2 is not equal to 0. 2 goes into the else condition. We recurse again. So it's 2 multiplied by factorial 2 minus 1, which is 1. So now factorial with 1. Again, it comes in here. Calls this, logs it again with 1. Again, it didn't multiply because it was too busy calling it. Now it's calling it with 1. So it logs it again with 1. 1 is not equal to 0. And so it skips that, recurses again. And this time, it's calling factorial 1 times factorial 1 minus 1 is 0. Okay? So now factorial with 0. It still didn't multiply it. But it comes back up here. This is now 0. It calls there. There's our 0 condition. It returns 1. Now comes all the returns. So it's returning 1. This finally gets returned from the previous call, right? So 1 times 2 is 2, which then returns 2, returns down here. And 2 times 3 is 5. 2 times, 5 times 4. And so it's just return, 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 return. And all the results do the multiplication at the end.
I've been reading about this in like very different formats. I really needed to see this kind of demonstrated. I guess.
Yeah, exactly. Yeah, you have to have it sort of explained in process, and then you get it.
But I need to know then, okay, so at what, in this kind of, because there are 3 different types of functions. There are functions that call themselves, or you know, like arrow functions. There are
yeah, but an arrow function is just a syntax for implementing a function, right? There's ways of implementing a function.
Declaration. There's a function. There's a function declaration, a function expression, and then there's arrow functions, which I guess.
Yeah, so arrow functions is basically like a function expression because you're doing it in a single line or multiple lines, but they evaluate as inline functions. So those are they're basically the same or very much related. It's kind of different words of saying the same thing.
So this would be a function declaration, but in this scope here, I understand the condition, what's going on. What I was having trouble understanding when I was trying to put in numbers within the parameters within the function scope, or I mean the function
signature.
Sure, the function signature. So this data here is what changes, but it's a fact. Okay, so factorial. So I'm just trying to see where the value that doesn't change live. It lives within the function. So when this data type so we put in the parameters in the function signature, we put in 4, right? And it goes through its iteration, or it goes through its condition, and so it becomes 3. So then the data type is, so then when it actually comes here, it's 3.
Well, it's basically calling a new instance of the function, right? It's calling it again with a different input. It does some math, calls it again with some different input, calls it again with some different input.
I'm not gonna okay, it's just I was overcomplicating it with a bunch of numbers. Like if we have even more parameters within the functions, within the function expression, it gets super complicated.
It can, yes, absolutely. It can get very complicated, and I've got other functions that I've implemented inside my platform that absolutely have extremely complicated, and sometimes it's a recursion that involves 2 or 3 different functions, where you have a recursion function that calls another function that calls another function, and then somewhere down deep in that other function, you call back to the recursion function. So this is a single function recursion, but you can have multiple function recursions as well. It just depends on how sophisticated your problem is that you need to solve.
I also and that has to do with, I guess, how binary counts or something. But
well, when we run this, you'll see it run, and it'll make a lot more sense. But yeah, just don't confuse the subject, and when you see it, you'll start to learn a little bit more about how it's working. So absolutely. Very basic at this point, but we got to start somewhere. So let's just keep going. We do need to set up our module exports. which again are done with arrow functions. Again, our syntax here is a little bit rudimentary because we're not fully following ES6 syntax with our imports, with our requires instead of imports, and the module exports. But yeah, we can do module. So the syntax here for this exports is probably not the best. I mean, but it'll work. We'll just go through it, and when you get into the other training sessions, then you'll see some other ways of doing things. Module dot exports equals curly braces, and then we do a square bracket, and then inside single quotes we have the name of our function with a colon, and now we need to pass the parameters. So data1, data2 are inputs to an arrow function that calls our function. Data1 and data2.
This is done within the export.
Yes, and now we just you could copy paste that, I guess, because we got to do a bunch of times. But you have a comma at the end, and we do this 4 times, and we just change this to subtract, and try to follow the same order so that your order matches what's in here. Whatever syntax you're following, you always want to try to keep your order of what it is that you're exporting with the order of the functions in your code, right? So that it's easier to track sequentially. If you get mismatches in order, then your code just becomes a little bit more confusing, and that adds tech debt, which adds entropy and makes things all kinds more confusing, which we talked about earlier, right?
Oh, it's not an execution thing. It's just
it's an organizational thing, right? If you're keeping your things organized, then it'll be easier for you to work with, and easier for everybody else to work with too. Divide, paste that there, and then we've got the last one, which is factorial. Factorial. Okay, and it only has one data parameter, and it's just data, not data1, data2. So make sure to remove the extra parameters. And we don't need a comma at the end because it's the last one. It will have a problem if you have commas inside object arrays like that if it's the last one. So yes, it does on the very last line. So yeah, that last one, we want to...
Yeah, it's just data, okay.
Yeah, just data. I mean, it doesn't particularly matter because it's a function that's calling a function, so you're not actually... It's not the same thing. So you could call it my data is calling factorial with my data. It wouldn't matter because that is separate from the actual function. So they're not correlated, but we're following the same syntax just for ease of programmability and readability and understanding and all of those things. So it is a good best practice to sort of mirror what it is that you've implemented there. All right, so the next piece that we need is now that we've actually implemented all of this, our library is complete. Now we can go back to index.js, and this is where we start to implement to call and use that library. So coming back over to here, and we're going to do this the messy way first, which is what we're going to have to do. After this if, we need to make sure we're doing this right. Yes, right after this if, the second if, the bottom of that curly brace, we need to do an else if command input dot to uppercase dot trim equals add. And we're using that same to uppercase so that we don't have to do like what we did before with the comparing with uppercase, all uppercase add, and uppercase the first letter add, and the all lowercase add, right? We don't want to have to do all of those comparisons because the code is going to just blow up. So we learned our lesson the first time from the exit, quit, q, x to do this to uppercase. We're following that same principle here. So if it equals add, right, we have a new block of code we're going to implement. Let's see here. Did we do? Yeah, we did declare our input data 1 and input data 2. So we're going to say input data 1 equals an empty string, and input data 2 equals an empty string. And then we'll say input, just to make sure, because we're in a loop. Remember, we're in a while loop. We want to make sure that the previous time that the user went through the loop, that there's no garbage data left over in these parameters, because they might be going through this loop multiple times. So data 1 equals prompt. And actually, before we do that, we should do another while loop inside of here. So while, you know what, we do need another argument up here just for temporary. Let valid input string equals false, and we need that. So if we say, we're going to say while not valid input string, and this is our while loop. I'm going to get rid of this stuff here at the end because that's not going to go there. So inside our while loop, input data 1 equals prompt dot prompt, and our message here is going to be enter the first number to add. Enter the first number to add. Colon space. We want to make sure we have a space at the end. That semicolon at the end, and then we say there's a check to make sure that the user entered something valid. So we say if not, that's not, the not parameter is a exclamation mark. Well, I used that up here already actually, but it's basically the negation or the opposite of however this is going to evaluate. Let me describe this while a little bit. It's as if I had written equals true. Okay. Now the not makes it false. So I could take this not off and just change this to false, and that would be the same thing.
A not could be like a shorthand for a if-else.
No, it's not. This is a negation, so it's basically saying, you know, like, I don't know, when you're little kids, you have this this game you play, opposite day, right? You say everything is opposite, you know, so that's what we do here. So what I've written here is while valid input string equals false, and now I'm going to change this to that, which makes it not, which would be the same as if I had written true. Let me make it a little bit clearer for you. I'll just copy paste this and I'll write these in equivalence format. So that is one way. And if I put this and this to true, oops, I messed that up, true. So these are exactly the same. These are saying exactly the same thing. Okay? And I'm gonna do another equivalence, and I'll say that while not valid input string, and the true just comes off. So these, all three of these are saying exactly the same thing.
Okay.
All right. Just for clarity, because I could say that, I could say this, I could also just say this. Now, which one of those is shortest and easiest to understand? It's that one. This part over here is implied, right? Because this is going to evaluate as, if this evaluates as true, then I want it to exit the if condition.
Okay, got it. All right, cool. All right.
So
it's a Boolean almost.
Yeah, I mean it'll evaluate as a Boolean as part of the while condition right here, right? I just wanted to sort of get that, you know, it's a little bit to get your head around, but it is true. That's why we do that. Now we say if is nan, not a number, parse int input data. Oh, and this is, what am I saying? Input, yeah, input data 1. Okay. And then we do a curly brace there. And again, this is sort of getting your head around this not is not a number is a little bit difficult, but it's basically not, right? Because
Not, yes.
Right, it's the opposite of the opposite, which is the original, right? So
Not a number, but it's a value.
it's not a number, which means it is a number, right? So that's how that works. It's kind of wonky, but it does. That's like the way it works. So then we're going to say valid input string equals true. So now we're assigning it to true, which that means finally after that means we're going to be getting out of this while loop as soon as we're done with this. So then we say input data 1 equals parse int input data 1. And we probably should have separate input datas, like input data user and input data value. Yeah, that might be better. Let's do that. Input data user. And we'll change all of these to input data user. Input data user. Input data user. and this one will be input data user, and then I'll declare two more of these, and I'll call them input data value because they're going to be parsed. They'll be parsed into actual values. And then we'll say this one goes here. Input data value 1. Now, the reason why we do that is because, and let me just come down here after the while loop, because we're going to have, when the user enters with this prompt, the user is going to enter a value. And how that value gets captured is it's going to basically be input data user 1 would equal like 6, for instance. Okay, but notice this right here, I put 6 inside quotes, and that's because it's a string. So what the user types into the command is going to come as a string, right? But strings, you can't, I mean, you're not going to really add strings. You can add them together and it'll concatenate them together as, like if I say add 6 and add 2, it'll make 62, right? But 6 plus 2 is not 62, right? That's not the value we're looking for. We're looking for 8. Right?
Yeah.
Not 62. So that's what happens when you do strings. So we got to make sure we convert it.
JavaScript.
We need to have this equal to 6, like that, a number, not a string. Because now when I add two numbers, they will add together, and the result will be the sum, not the concatenation of two strings. Does that make more sense?
Yeah, we're creating our own type.
I just wanted to show you this because I put this in here so you would understand a little bit better. Okay, so I'm deleting that. But now let's come back up. Now we've got to actually, now that we have our, well, we got to call the second number. This is just input user data 1. Okay, so now we need to do the same thing again. While not, oops, you know what? Before we do that, we have to say valid input string is reassigned to false. So we got to reassign it because now we're going into another while loop with this same value, and we want to make sure that we're not, oops, my while loop is not spelled right. We want to make sure that we're actually going into this while loop with the proper condition. Otherwise it's going to go in and it'll just go straight back out. We won't actually process anything. Okay, but now we say input data user 2 equals prompt. Oops, my autofill is going wrong. Prompt. Enter the second number to add. If not is not a number. Parse int input data user 2. Okay, valid input string equals true, and input data value 2 equals parse int input data user 2. Okay, so now at the end of that while loop, we've got two while loops that are both validating that the user entered a valid value for 1 and a valid value for 2. Oh, that's just a typo. I got a typo down here. Okay, now that should go away. Yep,
Wow.
there it is.
Can I?
So now that we've done this, we've actually got our two values, input data value 1 and input data value 2. And now we're ready to go do our operation. So we'll say let add result equals my math dot add input data 1 input, oops, I can't say input data value 1 and input data value 2.
Okay.
Well, finally, we say console.log, single quote, sum is colon space plus add result and a semicolon at the end. Okay, and that's the end of our add condition. Okay, yeah, no, that's a great sort of repurposing of a way of doing the same thing. I mean, it just clarifies what operation that was actually done. Now, I want you to think about something. So we got to highlight everything inside this add block. So it goes down to there. This is where it ends. And basically, that is our add code, right? That's doing the add operation. Now, if you think for a minute, we're going to have this 5 more times, or 4 more times. This is the first time we got subtract, multiply, divide, and factorial. Now, it'll be a little bit different for factorial. We'll only have 1, because we're only getting 1 data input instead of 2. But you could still imagine we got to copy this again and again and again and again. It's going to be a lot of code, right?
And you're trying to get me to the point where I can do this for all of your operators within your engine?
No. We're just learning coding. I'm just teaching you coding. That's all this is. Okay. But I'm trying to impress upon you the necessary requirements that we've got a lot of code, and it's going to copy this code, and we're going to copy it again and again and again, right? And it's going to be duplicated code. And then we're just going to change a few things here. We're going to change this from add to subtract. This will change from add to subtract. That'll change from add to subtract, and this will be from add to subtract result or something, right? So there's only a few things that are changing here. Well, that's what functions are for. They're for parameterizing, right? So if we take this code, instead of copying and pasting it, we could implement certain sections of this code and then make it parameterized, and then we just call that code instead of copy pasting and copy pasting and copy pasting. So there's a way that we can refactor this. I'm trying to get you to think here, because that's what we got to do as programmers, right? The best way, I think, oops, I had a typo right here. The best way to do this, I think, is to reduce this part right here, because this is the part that's duplicated down there. So if we could take this code and turn it into a function, it's going to reduce our entire code base significantly.
For the other operators,
Yeah, because instead of having 1, 2, 3, 4, 5, 6, 7 lines of code multiplied by 2, multiplied by 5, that's what's that work out to? Instead of having, let's see, 1, 2, 3, 4, 5, 6, 7 lines of code multiplied by 2, because there's 2 for every data, multiplied by 4 is 56 lines of code that we could reduce down to 2 times 5 or 4, well, roughly 2 times 5 would be 10 plus, 6? So 16 lines of code, approximately. So instead of 56 lines of code, we could do all of this in 16 lines. So you see how much it's going to save us from having to scroll and scroll and scroll through 56 lines of code just to read all of this stuff, and then you got to understand it, and if you ever need to debug it, then God forbid, so it just gets more and more complicated. So let's be smart about this, and let's put all of this into a function. So how do we do that? Well, parameterize. We know that this message is going to change, and so we can make the message into a parameter variable, right? And then we'll just return from that, because the rest of this is there. So let's go ahead and make a new function down here, and we'll say function get user input, right? And this will allow us to validate that input, but we've also got to keep all our boilerplate code in here too. So maybe it won't be quite 16 lines, but we're definitely going to save, and the complexity will be way lower. We'll say message. Okay, so that's what we're going to pass as input to the function. Come up here, do the header like we always do. At function, get user input. At description, gets an input number from the user and validates that it is an integer. Okay, the parameter is a string. Message the string message to query the user for input. And then return at returns integer, an integer value converted from the user input. Sign it with your name and date. 0613. Okay. And again, we have our boilerplate code, which now that we've got our boilerplate code, we can just go back to my math and we'll just copy paste our boilerplate code from factorial or add or whatever, it doesn't matter. Copy paste and change the input, just like we always do, the name. And we've got console log. So this message needs to come down. Instead of data, it's message. We're going to leave the return data. Let return data equals 0. We're going to leave that line in there because we're going to need it. But we're going to wipe out the rest of this if condition stuff because that was the implementation that I copied. We don't need that. We don't want it. We want our own implementation. All right, so now that you've got that in place, we're going to go ahead and do the implementation, which the best way to do this is to just copy paste this while loop because that's what we're trying to move into our function. All right, so I could just copy paste this, drag it down here, and just paste it right there. Now I might have to indent my formatting a little bit. Let's see here. I guess it's this like, let's see here. Where does this, oh, this needs to come out. My formatting was off there. Oh, wait a minute. All of this stuff is off. There we go. Okay, that's better. Okay, now we've got a couple things we've got to do different. So we got our return data, but we also want to say let input data. We'll just declare it. I'm not going to assign it to anything. And I'll say let valid input string equal false. So we're declaring all of that stuff there. Now our valid input string comes here. And we can just change this to input data and take off the user1. That's input data. This one also take off the user1. It's just input data, simplifying things. And then when instead of input data value 1, we're just going to say this is return data. So I'll put that there. Again, over here, user1 comes off. And instead of this string that says enter the first number to add, I'm just going to put message there in place of this string. So we're just forwarding that message on to the prompt. Let's save that. And we're still doing our return data. We're logging, and everything else looks completely kosher from this implementation. So now that we've done that, we're ready to go up here and replace our while loops with calls to get user input. So I can take this, the section of code that I commented out, the while block, all the way down to the closing curly brace, and press Control / and it'll comment all of it out. And now we can just call, well, first of all, I need to say input data value 1 equals get user input. And I'll pass it this same message, enter the first number to add. And I'll put that right there. And I'm just going to do it for 1 right now. And let's go in and make sure all of this stuff is working because we've never actually even tested this. So it's probably a good idea to go in and test. And also, I don't think we have our math. My math is not imported up here. So that's another thing we need to go do. And if we look in the order up here, we have source, index, my math, and then prompt. So we want my math to be before prompt. So first in our header, the file header for index, we need to add our my math up here. So requires module my math, and then we add it down here as well in the internal imports before prompt. So we're maintaining order. The order of our files in the Explorer is matching the orders of our imports in our code. So let my math equals require dot / my math. Okay, so now we've imported it. Save that, and it actually should work. This should run, and let's see if I've got any bugs or if you've got any bugs. It's sort of good to test at this point. So we've got this set up, and I'm loaded here. CLS npm start, and here we go. Okay, so enter math operation, and we've only implemented add from the user interface perspective. So I can say add, enter the first number to add. So we can see here, it looks like it begin application.index.getUserInput function. Message is enter the first number to add. Begin prompt.prompt.prompt. Ask is enter the first number to add, and there it printed the message. Enter the first number to add. So let's just say 1, and enter the second number to add, 2, and there it gave the return result is 3. Sum is 3, and now it's asking for the next operation. So excellent. So that worked for me. Well, we're not done. We're not done. Let's get a little bit further along. I mean, I don't know if you still have some time. I mean, now that we've done this refactor,
sure.
That's what this is called, by the way. When we remove this code and we refactor, we're taking some code and moving it into a function, and we're simplifying the code. So we can just remove this code now, right? We don't want to leave it in here.
Okay, I just want to look at it.
Well, yeah, if you want to leave it for reference, you could leave it, but only leave it once because we're going to go ahead and simplify all of our other code. But so now the second time we do this is the second input. And now we're going to simplify our code a lot. So I'll comment this one out, the second while loop, and we'll call input data value 2 equals get user input, enter the second number to add. We'll just copy paste this from right there. Okay, and now that should now work, and we can get rid of these. Oops, wait a minute, hold on. Yeah, we can get rid of input data user 1 and 2, can now go away. That gets deleted, and valid input string can also go away. And I'm going to remove this while loop. Just take that out too. Don't need it. And this valid input string equals false. We don't need that because it's all managed inside our function. And now we've taken all that big block of code and we've consolidated it into just like 3 lines of code. So you see how much simpler that is? So much simpler. That's the next task, is try to implement all of these. And I'll let you do that, and then we'll come back and review, what you do as far as your own exercise. And then we can make alignment to make sure you have good understanding.
Yeah, totally. I think I can.
That way it's not me just dictating everything. You should be able to do this now that we've got, this good code right here. And you can test it out again. You probably want to test it out again to make sure that what you have right here is working. All right, so there's a couple things I need you to fix that'll help. So coming down, go back up, all the way up to where you call your get user input and you assign it to input data value 1 and input data value 2. Just above those, go ahead and write input data value 1 equals an empty string. I'm sorry, equal to 0. And input data value 2 equal to 0. Okay, so that should be enough for you to now go and propagate this. You've got the add operation, and now you should be able to add this for subtract, multiply, divide. Once you've done that, then we'll come back and I will implement it and show you how I've implemented it, and you can compare my implementation with yours. And we also can check and test it and make sure that all the operations are working like they should. We'll do that.
Watch me do that. Yeah, you're busy. You got something to do. Let me do the function. Let me get subtract and divide.
All right, I'll talk to you later. You have a good day.